Hello, my students, and welcome to this tutorial. In this short tutorial, I'm going to show you some basic concepts we have studied before. And firstly, what is the meaning of the function? The function is a relation between two sets. So if I have a set like the set X, A, B, and C, and the set Y, let's say X, Y, Z, L, and A is related with X, B is related with Y, C is related with Z. So this relation is a function. Why? Because each element in X is related with an image in Y. For each element in X, there is an image in Y. And if I have a linear relation like Y equals 2X plus 1, in this relation, for every value of X, when we say X, let's say X equals 0, what is the value of Y? If we put X equals 0 in this relation, you will find Y equals 1. So 0 is connected and related with 1. 0 and 1, the order, the pair 0 and 1. And if X equals 1, for instance, what is the value of Y? Y equals 2 times 1 plus 1, which is 3. So 1 and 3. This is the simple definition of the function. But when we say y squared equals x plus 8, if I'm going to substitute x equals, let's say 1, what is the value of y in this case? Y squared equals 1 plus 8. So 1 is y squared equals 9. So we have two values for y, positive or negative 3. So when x equals 1, the value of y equals positive or negative 3. We have two values for y. So this relation is not a function. Once again, 1 is related with 3 and negative 3. There are two images for the value of x when x equals 1. So this relation is not a function. If the function f of x equals 3 over x plus 2, what is the domain of the function? And simply, what is the meaning of the domain? The meaning of the domain means all values of x we can get. And if you looked at this function, we can find any value for x except zeros of the denominator. So when we put x equals negative 1, so if negative 2, f of negative 2 equals 3 over negative 2 plus 2 equals 3 over 0. So this is undefined. So what is the domain of this function in this case? The domain equals r difference negative 2. Once again, why the domain is r difference negative 2? Because we can find any value for x except negative 2. Because negative 2 makes the denominator is equal to 0. If I have a function like f of x equals square root of x, what are the possible values of x we can get? We can get any value for x except negative values. So we can find f9 equals the square root of 9, which is 3. We can find f0 equals the square root of 0, which is 0. But we couldn't find f of negative 9 because there is no square root for a negative number. So what is the domain for this function? The domain x must be greater than or equal to 0. x must be positive or 0, okay? So the domain in this case, we can represent it on the number line. We can find the value of 0, and we can find all positive values. So the domain in this case is 0 and positive infinity. 0 and positive infinity. If I have a function like f of x equals 3 over square root of x, what are the possible values of x we can find? We can find any value for x except 0, because however, I can find the square root of 0, which is 0, but we couldn't put 0 in the denominator. So we couldn't find the value of 0. And because the square root of x, it's in the denominator, square root of x, so we couldn't find the square root of a negative value. So the domain in this case is 0 open and positive infinity. And what is the difference between this question and the previous one? The difference between them, in the second question, we have a square root in the denominator. So we couldn't find the value of 0, square root of 0, because the square root of 0 equals 0 simply, and we couldn't put 0 in the denominator. So the domain in this case is going to be 0 open and positive infinity. Okay. If I have a function like f of x equals x squared minus 3 over x power of 2 minus x minus 2. What is the domain for this function? If we look at the function, we have numerator and denominator. We couldn't find the value of the function when the denominator equals 0. So what is the first step? The first step to find the zeros of the denominator. So put x squared minus x minus 2 equals 0. Then factorize. I'm searching for two numbers, their product -2 and their sum -1. The two numbers are -2 and +1 equals 0. So the first value of x minus 2 equals 0. So x equals 2. And x plus 1 equals 0. So x equals -1. You know, we couldn't find the value of 2, and at the moment we couldn't find the value of -1. Once again, what I said, we couldn't find the value of 2, and we couldn't find the value of -1 because 2 makes the denominator is equal to 0, and -1 makes the denominator 0 when we put x equals -1. So in this case, we will write the domain as all real values, all real numbers except 2 and -1. So what is the domain in this case? It's all difference 2 and -1. What about the numerator? I have no problem in the numerator because we can find any value for x in the numerator, but our problem in the denominator. If I have a function like f of x equals 3x minus 50, what is the domain in this case? I told you before that we can find any value for x except negative values. So 3x minus 15 must be greater than or equal to 0. What is written under the square root, 3x minus 15, must be more than or equal to 0. Once again, what is written under the square root must be more than or equal to 0, must be positive or 0. So I wrote 3x minus 15 greater than or equal to 0, then 3x greater than or equal to 15 divided by 3 both sides, then x more than or equal to 5. So what is the domain in this case? The domain on the number line, we can find all values of x starting from 5 till positive infinity. This is the domain of the function. So the domain is 5 closed and positive infinity. F of x equals square root of 18 minus 6x. We will follow the same steps as I told you. What is written under the square root must be greater than or equal to 0. So 18 minus 6x must be greater than or equal to 0. How can we solve this inequality? Move 18 to the next side. So minus 6x greater than or equal minus 18. What is the next step? I want to get rid of minus 6, so divide by minus 6 both sides. You will end up with x, and remember that when we divide by a negative number, we will change the direction of the inequality. So in this case, x will be less than or equal 3. Once again, when we divide by a negative number, we change the direction of the inequality. We divided by negative 6, so I changed the direction of the inequality. I changed the direction of the inequality, as you see. So x less than or equal to 3 on the number line, 3 less than or equal to 3, so we will go in this direction. So the domain in this case is going to be domain equals negative infinity and 3 closed. What if I have f of x equals 1 minus 5x over square root of 30, 6x minus 30. I don't care about the numerator because there is no problem in the numerator. We can find any value of x, but when we go down in the denominator, you will find that I have square root of 6x minus 30. And in this case, we can find all square roots except negative values. So in this case, 6x minus 30 must be greater than 0, not equal to 0. Why? I couldn't write more than or equal to 0 because 6x minus 30 is written down in the denominator. So 6x minus 30 more than 0, greater than 0 only, not equal to 0. So move 30 to the next side, 6x greater than 30 divided by 6 both sides. You will end up with 6 greater than 5. So the domain in this case is going to be 5 open and positive infinity. That's it. What if I have f of x equals the square root, but in this question I'm going to write quadratic equation like x squared minus 9. So we will follow the same steps as I told you. X squared minus 15 minus 9, sorry, must be greater than or equal to 0. Positive and 0 only. We can find all positive values and we can find the square root of 0. But how can we answer this? How can we find all positive values and the 0 values for this relation? So the first step, we will put x squared minus 9 is equal to 0. Then we are going to factorize x plus 3 and x minus 3 equals 0. Then x equals minus 3 and x equals 3. And on the number line, negative 3, when x equals negative 3, the value of the function is going to be 0. And when x equals 3, the value of the function is going to be 0. Now I'm going to determine the sign of the function. And if you are going to take a value for x greater than 3, like 100, for instance, and we substitute x equals 100, so 100 squared minus 9, it will be a positive value. Okay? And if you are going to take a negative value less than negative 3 and put instead of x like negative 100, squared minus 9 is going to be positive. And in the middle, negative. So I determined the sign of the function. And after that, what I need focus and pay attention. I need positive values and I need 0 values. So just to take true on the positive values, we can find all these values. And also we can find the value of 3. But we couldn't find the value of any number between negative 3 and 3. And on the left, we can find all values. And at the moment, we can find the negative 3. So what is the domain in this case? As you see on the number line, we can find 3 because 3 makes the square root 0. We can find the negative 3 because negative 3 makes the square root is equal to 0. And we can find all values which are greater than 3, and we can find all values which are less than negative 3. So what is the domain? We can write the domain using 2 ways. We can say that the domain is 3 closed to positive infinity, union, negative infinity, and negative 3 closed. And we can write the domain as, because as you see, we have taken all the number line. So we can write all the number line which is our difference. Pay attention. Our difference negative values. Our difference negative values of the function. And negative values of the function start from negative 3, after negative 3, not negative 3, till 3. So we can write the domain as R, which are all the number line, except the difference from the negative 3 till 3, but negative 3 open. Okay? What if I have f of x equals, let's say, x squared minus 25, and I don't have any problem in x squared minus 25 because x squared minus 25 is written up in the numerator. And I have down x, let's try 36 minus x squared. Look at the function again and determine all possible values of x we can get. Actually, we can get all positive values only for the denominator. So 36 minus x squared must be greater than 0 only. Positive values only. And why again positive values only? Because the square root is written down in the denominator. And when we have a square root in the denominator, the square root must be greater than 0, what is written inside the square root. So how can we determine the sign of this equation? 36 minus x squared. So firstly, put 36 minus x squared equals 0, and then factorize 6 minus x and 6 plus x equals 0. You will end up with x equals 6 and x equals negative 6. So we have two values. The two values make the denominator equal 0. So on the number line, we have 6 and negative 6. Negative 6 make the function is equal to 0, and 6 make the function equal 0. Okay? What about the sign of the function? The sign of 36 minus x squared. Simple. I told you many times, to find the value of the function in this area, just take a value greater than 6, like 100, just to remember. Okay, I always say my 100. Why? I'm saying 100 all the time, just to remember it. So taking 100 leads to get 36 minus 100 squared. So it will be negative. Any value you are going to take more than 6, okay, makes 36 minus x squared negative value. And if you are going to take a value less than negative 6, like again negative 100, okay, so put x equals negative 100. It will be 36 minus negative 100 squared. It will be negative. And in the middle, positive. To put it at ease and make it simple, more simple. On terminals of the number line, on the two terminals of the number line, the function, the sign of the function is going to be like the sign of x squared, like the coefficient of x squared. And as you see, if you looked at the function, I have negative x squared. So on the two terminals of the number line, they are going to be negative. And in the middle will be positive, the opposite of the sign of x squared. And what I need all positive values only. So where are the positive values? I need all positive values. As you see, I'm taking true on the positive values. And the positive values start after negative 6 and before 6. So the domain in this case is going to be negative 6 open and 6 open. That's it. I hope you enjoyed this session. See you the next session. Goodbye.